we did number 5, A and B last time. And we're on to 5C. Remember, we're talking, this is 11.3. This is the conclusion, hopefully. We'll see. This is more of 11.3. And we're on part C up there, which is all about some facts about angles and triangles. Specifically, remember what we learned? All these have two parallel lines cut by a transversal. Remember what we learned about two parallel lines if you cut through with a transversal. So if a line cuts across two parallel lines, remember that we learned that all kinds of angles are equal. In fact, way back here, they called it, right there, they called it corresponding, alternate interior, or alternate exterior. All those different ones, they're different kinds of angles. All those sets of angles will be equal when you have two parallel lines and another line cuts across it called a transversal. I tried to make it as easy as I could by saying you basically look for Z angles. Remember that? So if you have a Z, like this Z right here, the two angles that a Z makes, what those are going to be alternate interior. That's the ones that are often easy to see if you make a Z. Alternate interior. And by the way, you can also do the Z backwards. Like this. Those two, same thing. They're still just alternate interior angles, and they will be equal. So we look for those in the diagrams. We also look for corresponding. Remember what corresponding are? Like upper left. See, for these two intersections, those two angles are both in the same position of the intersections, aren't they? They're both upper left corner. So those are called corresponding. Anyway, so any of those will work. If you can find any of those that are equal, then you know the two lines have to be parallel. Or vice versa. If you know the two lines are parallel, then you know those angles are equal. So that's what we're talking about. So getting back to part C, we're looking at this situation here. And we're saying, okay, they're giving me a couple angles. They're giving me this angle here is 66, and this angle here is also 66. Does that mean that top line and bottom line have to be parallel? Yes, for sure it does. Do you see it? Why? Do you see that that's basically making the Z thing? Right? If I bring this, and like that, those are Z angles, aren't they? Backwards, Z angles. And if Z angles are equal, the lines have to be parallel. Do you sense it? Do you kind of feel it? A lot of geometry, is looking at pictures and sort of gut level feeling it. Like if that 66 was a little bigger, was like 70 or 75, do you see how that would make the line go up and no longer be parallel to the bottom one, huh? If that was a little bigger angle than 66. Do you see that? As long as those two angles are the same coming off the transversal, then it's going to make the top and the bottom parallel. So basically, you just look for Z angles, and if you happen to see two Z angles that are equal, like we do in this picture, then that means for sure those two lines are going to be parallel because they're coming off at the same angle on the Z's. So let's go over here. Now, so the answer is yes on part C. I'll give you a hint. The answer is yes on all these questions on number 5. By the way, all right, anyway, so let's go to C. The answer is yes. Now, which one of those yeses is the right yes? Because alternate interior angles are 66 each? Yeah, that's exactly it. What's that other one say? Adjacent angles? No, it has nothing to do with that. It's alternate interior, right? Those are the kind we do. Alternate interior or corresponding or alternate exterior. It's always going to be those for the Z angles and the two parallel lines cut by a transversal. Good there. Let's go to D. Look at picture D. Feel free to stop me. I'll be moving fast, but you feel free to stop me. It'll also be on YouTube. So why would these two lines be parallel on picture D? You got those two 90s. Are those two 90s, one of the important angles? Alternate into, they're not Z angles, are they? But they're corresponding. Does everybody see that those are corresponding? What do I mean by corresponding? I mean this is the upper right-hand corner and this is the upper right-hand corner of those two intersections. So it's like you're going down the street from one signal light to the next, and those are both the northeast corner, right? Those are both, the upper right corner and the upper right corner. They're corresponding. Corresponding. So if you have corresponding angles that are the same, then that means the two lines have to be parallel. So again, we have the three sets, right? You can have corresponding angles, alternate interior, Z angles I call them, or alternate exterior. It's usually going to be Z or corresponding. If you can just find Z angles or corresponding angles, you got it. That's 99% of the time. So what does it say on D? Are they parallel? It's going to be one of those yeses because corresponding angles are 90. That's right. There it is. We good there? All is well. Now, how about E? Can we do on E? What are those angles? Yeah, they're actually alternate here. That's great if you can already see that. Yeah, these two lines must be parallel because this angle and this angle are the same. Those are alternate exterior, right? They're both exterior, they're outside the parallel lines, and they're alternate, they're on opposite sides of the transversal, right? The top one's on the right of the transversal, the bottom one's on the left. So that's alternate exterior. So if we go back to, where's E? Yes, because, not vertical, no. Yes, because alternate exterior. There it is. That's the reason why there. We good there? Questions so far? It's making sense, just identifying those. And now, question F. Question F's kind of terrible. Let's reason our way through question F. It's pretty challenging. In fact, maybe it would be best. Notice this little fact down here. X equals Y plus Z. I think I'm going to take that one to a fresh diagram. Let's see if I can remember it. So X in the center. Okay. X in the center, Y and Z. X in the center, Y and Z. Okay. This is 5F. All right. Let me go over here. We got some room. Got to try to show you this a little bit better. All right. So number 5, part F. So we have like a line here and a line here. And I think it goes like that, right? This is X, and this is, wait, I already kind of forgot. Where's Y and Z? Oh, yeah, that's right, X, Y, and Z, just like that. And X equals Y plus Z. Okay. Okay. X equals Y plus Z. Bless you. All right, so and then they tell me X equals Y plus Z. All right. Are you ready? It's going to be a little bit fancy, some fancy math. In fact, well, it's going to make it bigger, but I guess it's big enough. Okay. So you ready? So notice how we don't have any Z angles or anything. So what we should probably do is just extend this like that. So I'll do that a lot on some of these ones. They have something happening in the middle, but they never quite connected them. You want to make a Z. You want to make the two parallel lines connected by one straight line like that. And then do you see the Z now? It's a backward Z, right? If I go along this, like this. So that's a backward Z. I could have done it the other way. I could have extended this line instead and made a forward Z. Whatever. It'll work fine either way. So I'm going to go ahead and make a backward Z. Okay. And, okay, so what? What does that mean? Remember, Z angles are equal, huh? So if this angle right here is Y, do you see the other one that's got to be the same thing? It's got to be this one here has to also be Y, doesn't it? Is that too small? Can you see that? Right? Because those are Z angles, aren't they? So if those lines, I'm trying to find out if those lines are really parallel. Oh, no, I think they said they're parallel, and they want me to find X, didn't they? I better get that straight. Let me go back. This is a tricky question here. I'm on F. They're saying, they want me to find Y or Y not. Yeah, do they have to be parallel? Okay, yeah, so that's right. So if they're parallel, if they really are parallel, then those two z angles would have to be equal, wouldn't they? They'd have to both be y. Okay, great. So what? So next, this is a more advanced one here. Is there something I can do to find that little blue angle right there, the top of that triangle? Notice that together, the x and that angle make the left side of that green straight line, the middle of the z. They got to make 180 together, don't they? Do you see that? Let me draw that in a little bit better right here. Do you see? Or here, do this. Okay, so this straight line, right, that little piece of line there, the x and that blue angle have to make 180. Because, right, one side of a straight line always makes 180, right? So that little blue angle there has to be 180 minus x, doesn't it? Do you see that? Whatever x is, the other one, the little blue, the top of the little triangle, has to make 180 minus x because together those two make 180 degrees. Right? For example, if you had a straight line and you knew this was like 70 degrees, how could you find that? You'd say, oh, well, that one must be 180 minus 70. It must be 110. So that together they make 180, for example. You know what I mean? I'm just doing numbers to make it more concrete. A lot of times that helps. If you're teaching people stuff with letters, I found it really helps to put in numbers. We just think better with numbers, than we do with X. So yeah, right? That makes sense, what I'm doing there then? So because these two are one side of a straight line, they must make 180. Same thing here. These two are one side of a straight line. They must make 180. Okay, great. I see it. But what is all that going to do for me? Well, now I have the three angles inside that little triangle. So I can add those three up to be 180. There's several steps to this one. So the z, right here, this one, plus the y, this one, plus that top one. What's the top one? 180 minus x. All those must add up to be what? They're in a triangle. They must add up to 180. Because the three of them, right? The z, the y, and the 180 minus x, those are the three angles we all reasoned out inside that little triangle. Tracking with me? Those all must total 180. Okay, great. Well, is that working out? Let's see. Let's solve this little equation. Notice how they said x is y plus z. They told me x is y plus z, didn't they? So if that's the case, what does that mean? I'm kind of half tricked myself here for a second. Let's do it this way. Let's solve this little equation for x. What do I get in this little equation? Well, I can get rid of the 180 from both sides, right? Gone. And I get z plus y minus x is not 180, 0. Right? There's nothing over there now, right? 0. And now, can I get x alone? You just add the x over to the other side, huh? And so then what do we have? Z plus y equals x, which matches the original truth they gave me. X is y plus z. So in other words, yeah, it must all be fitting. I don't know if you followed with all that logic. It must all be fitting that those really are parallel lines because they agree with this relationship, x equals y plus z. How are we doing on that? So the ratio of the measures of two supplementary angles is 1 to 11. 1 to 11. And then find the measure of the smaller angle and find the measure of the larger angle. So the ratio is 1 to 11. Find the smaller and the larger, and they're supplementary. They're supplementary. All right, so how are we gonna do this if their ratio is 1 to 11? That means that one of them is x and the other is 11x. We can just bring in variables. I don't know what either one of them is right now, but I can say that one of them is x and the other one is 11x. That way one of them is 11 times bigger. That's what it means to say they're in that ratio. of 1 to 11. And they're supplementary. What does that mean that they're supplementary?
Adds to 180.
They add to 180. So the x, if I have some room, I'll come down here. The x plus the 11x must total 180 degrees. Is that making sense there? So I can solve that equation for x. So what's x plus 11x? 12x is 180. Get the x alone, divide by 12. X is it 15? 15, yeah, 15. So x has got to be 15. That's the smaller angle. What's the larger angle? How do we find the larger angle? Yeah, because remember they're supplementary. They make 180 total. So if you take 180 minus 15, you get 165. Or you could have just done what? Plug it in there, multiply by 11, because one of them's got to be 11 times the other. You can double check that. Is 15 times 11 165? It is. So there they are. There's the two angles. One of them's 11 times as big as the other, and they're supplementary. All right, that was a little bit better. Regular polygon. So what's a regular polygon? Yeah, perfect. It's a perfect shape. All the angles the same, all the sides the same. Yeah. Has each interior angle is 144. So in a regular polygon, every inside angle is 144. How many sides does it have? So we don't know how many sides this thing has. We want to figure that out. And they're telling us it's regular and the angles are 144. So let me get us a little bit of room there. So 144, number 7. So number 7. So it's a regular polygon. Each angle is 144. So how many sides? So how in the world are we going to figure that out? Remember we came up with a formula last time? You guys haven't been able to think about anything else since Wednesday, right? That formula we came up with? I'm sorry, I'm just joking around with you. I know you have other things in your life than my math class. I'll try to keep that in mind. So remember that formula we came up with right at the end last time? This formula? That's for the interior angle in a regular polygon. That's exactly what we're talking about in this problem. Let's use that now. So that formula, if you just plug in, it'll tell you how big the angles are in a perfect polygon. So let's take that formula and go back. There we go. So each angle, the angles are equal to n minus 2 times 180 over n. All right. So, and they're telling us the angle is 144. So pop in the 144. So 144 degrees equals n minus 2 times 180 over n. So we just have to find the n now. We have to find out what value of n makes that true. How many sides, right? What is n? How many sides to make it come out 144? How should we solve that problem?
Multiply both sides by n.
Yeah, you can totally do that. Cross multiply or multiply by n and then go on and solve. Can I make another suggestion? If you're comfortable, some of you guys are real good at algebra, and that'll be great for you to just whip it out. This one's a little harder algebra. It might be better to just guess. Is that okay for a math teacher to say that? I think I'm a math teacher, and I think so. Yes, I approve this message. Yes, using guessing is actually great as long as you check your guess. So that might be easier and quicker. So what I mean is, you can just plug in a number. Just say, I don't know, maybe it's 8 sides, and just plug in 8. Type 8 minus 2, which is going to be 6, right? Times 180. Whoops, times 180. My pen's kind of wigging out of me here. I'm going too quick. Times 180 divided by 8. So just hit the buttons on your calculator. What does that come out to be if you take, what is that, 6 times 180 divided by 8? You're going to get 135. So that came out too small. It's supposed to be 144. So I need to go higher. Right? So try 9. Try 10. So let's try 9. How about 9 minus 2? 9 minus 2 times 180 over 9. That comes out, I don't know what that comes out to be, 140. So we're getting closer. Try 10. 10 minus 2 times 180 over 10, and that's going to be at 144. So there must be 10 sides. So you can just do that by guessing. If that, I know probably that bugs some of you who are comfortable with algebra. I'll show algebra real quick if you prefer. So either way, put this over 1, cross multiply. I'm not going to take too much time in this because I don't got too much time. But if you're good with algebra, you could, whoops, that's supposed to be n, huh? Not 8. You can cross, but here would be the formal algebra way to do it. Cross multiply like that, and then you got to distribute the 180. 180n minus 360. Bring it up here. And then you got to solve for it. When you have n on both sides, you got to get rid of one of them. Subtract. So it's a little bit of work with algebra. So that's minus 36n, right? Yeah, is minus 360. Last step, divide by the minus 36, and then you get it. So that'd be the formal algebra way. It's probably easier just to guess. You can get it super quick with a couple of guesses. Either way, the answer is 10. This is a 10-sided object. All right, I better move on. All right, so that was number 7. Number 8, I think it's better there. Okay, yeah, number 8. So now they want us to find x in these diagrams. We're basically going to be just using the different facts we've learned. You know, like triangle holds 180, z angles are equal, side of a straight line's 180. They want me to find x right there. So how can we find that x? Let's take some steps using what we've learned. What's that? For which one?
The 45 degrees.
Oh, yeah. Yeah, what's this one have to be? Got to be 45 also. Yeah, those are because diagonal angles are always equal, huh? They actually call those vertical. I don't care what you call it. But it's diagonal angles, and they're always equal. Yeah. So vertical angles is the formal name. They're always equal. Yeah, so that's got to be 45 degrees because they're diagonal, and they're always equal. Very good. What else do we know?
The other angle has to be 180 minus 80, so it has to be 100.
Yeah, because those two are the right side of a piece of straight line, huh? So one side of a straight line always makes 180, doesn't it? So yeah, so that angle right there has to be, 100, right? 100 right up there to make 180, 180 make 180. And now we can find x, right? Just subtract from 180 because part of a triangle. Triangle holds 180. Everybody see the logic there? So we found the 45 degree because those are diagonal angles. Those are always equal. We found the green 100 because that and the 80 are one side of a straight line. They got to make 180. And now we have the 3 angles inside of a triangle. These 3 are making a triangle. So they have to make 180. So therefore, if the x has to be whatever the 180 is minus the 100 and the 45. Right? So it's 180 minus 145. And so what is that, 35? So x has got to be 35 degrees. Not too bad there. How about part B with the 3x and the 6x?
We do 3x plus 6x equals 90.
Yeah, they got to make 90, don't they? Because they're diagonal from this 90 degree angle together. Their total is got to be 90 degrees. Yeah, that's right. So this plus this. So let's do that. 3x plus 6x is 90. So 9x is 90. How do we get x alone? Divide by 9. X has got to be 10. So there we go. All right, we good there. And then part C is terrible. So there's part C. I actually did it there. So look at the time. That what are we going to do? That one's so long and terrible. How about yeah, you know what I'm going to do? That's just too hard. I'm glad to talk to you. This is it. If you'd like to talk to me about it after class, I'd be glad. I'm not going to put it on the test. On the homework, don't worry about it. The answer to this one, I believe, is, it's 144, right? It's 144. X is 144. It's just tough. I didn't realize how tough it was. I picked these. When I pick the homework, I kind of look at them and I think, oh yeah, that's probably doable. And then when I get in here with you, I find they're not always as doable as I thought. So that one's pretty tough. So don't worry about it on the homework. Just skip it over. Don't worry. At the end of the semester, don't worry about it. I can't change it at this point. Once the homework's out there and people worked on it, it won't let me change it. So I can't yank it. So, but don't worry about it. Don't worry about one little part. Just let it go. Put it in whatever answer. I promise I won't hold it against you in your overall grade at the end. So I'm going to skip it. I just don't think it's worth our time. It's a little bit fancy. So anyway, I'm going to move on with number 9. So determine the measure of an angle whose measure is 14 times that of its supplement. So let's try that. So determine the measure of an angle whose measure is 14 times that of its supplement. How are we going to do that? This one's not easy either. So we're talking about an angle whose measure is, whenever you see is in like a word problem, what is the is always? That's your equal sign. That's like the equal sign right there. 14 times its supplement. So the angle is, I don't know what the angle is, so I'm just going to call it x, The angle is x equals 14 times its supplement. Is that right? Not quite. But that's kind of a natural thing to do at first, but it's not quite right. Why is that not right? I didn't do the supplement anywhere, did I? See how I just, that would mean the angle is 14 times itself. But that's not what they said. They said the angle is 14 times its supplement. What is its supplement? How do we do it? Like if you have an angle, say I've got like a 30-degree angle. Okay, here's an angle. And then I want to find its supplement. What in the world does that mean? Well, what are supplementary angles again? Add up to 180. So what would the other one be that goes with 30 and together makes 180? Had to be 150, right? And then together they'd make 180. And now, how do you come up with that? You just take 180 and you subtract the first one, and that gives you your angle, huh? You with me? If two angles are supplementary, it means they add to be 180. Right? Complementary had to be 90, supplementary had to be 180. So if you have the first one, 30, you just take 180 minus that, and that gives you the other one, huh? So if the first one is x, what's the supplement? Same thing, 180 minus x. So that's the supplement, huh? So that's what I got to put right here. That's what they're saying. Now we need to solve that for x. Does everybody see that's what they're saying? An angle is 14 times its supplement. It's 180 minus x. That's its supplement. So we need to solve that equation for x. A little bit of algebra here. So I'm going to distribute that 14. And I'll get x equals, and whatever, use your calculator. I'm going to use mine too. 14 times 180, 2520. 2520 minus 14x. Good to there so far. So x equals 2520 minus 14x. How do we finish getting x alone? Add the 14. Yeah, when you have x on opposite, remember this from your algebra days? When you have x on opposite sides of the equal sign, you've got to get rid of one of them. So do the opposite of one of them. So I'll add 14x to both sides. Like that. And so the left side, what is 1x and 14x? 15x. 25, 20. And last step, divide by the 15, right? And so x is, somebody got it in their calculator? 168. Thank you. 1x is 168. So that was kind of challenging. Yeah. Question, Cami.
I did it a different way that's a little bit easier.
Yeah? Which is better. So yeah, so Cami's saying, she just said, okay, x is 14y. She just called the other one y, right? Because the angle is 14 times its supplement, right? Times its, the other one. And then the angle plus its supplement must make 180, because that's what it means to be the supplement. So she just had those two equations, and then you just took this and you plug it in there for x. Does that make sense? 14y plus y is 180. Nice. See that? And then that's the same. Then you're going to end up right where we ended up, because that'll be 15y is 180 divided by the 15. That is a little cleaner. So either way, good work. So whichever works for you on that one. Let's come on down to part B here. Part B. Two angles of a triangle are complementary. What's the third angle? I think if we draw this one out, it'll be an easy question once you see what they're saying. So they're saying we've got two angles in a triangle that are complementary. What does that mean, complementary? They add up to 90. So these two are complementary. So that means they add up to 90. So, what helps me is if I just put in numbers. Again, words, letters, hard. If you put in numbers, I think we do way better. Like, what if this is like 50, for example, and that's like 40? They got to be something like that. I think we think a lot better if we put in actual numbers, So 50 and 40, for example, they add to be 90. Could be 60, 30, who knows, whatever. But they add to be 90. So then the question is, what is the other angle, right? What is the third angle have to be? Yeah, now it's obvious, huh? It's got to be 90, because a triangle holds 180. These guys are using up 90. So the other one, that leaves him 90. He's got to be a right angle, doesn't he? Because there's 180 in every triangle. See how much better we do when we stick in numbers? Just put in numbers, and I think it'll be easier. All right, well, I've drawn all over number 10. I guess I'll have to erase my work. So number 10 has that big polygon there. And they want me to find that x. So how are we going to do that? How are we going to find x in that big old polygon? Yeah, nice. Yeah, and how do we find the total amount of all the degrees? Yeah, remember the formula? Exactly. Yeah, so we can just add all these up. Somebody got that in the calculator? So the total, and what should the total be? We had that formula, right? N minus 2 times 180. Remember that formula we derived last time? Coming back here. So I passed it, huh? Right here. Yeah, N minus 2 times 180. That's the total degrees inside any insided object. That's different than this formula, which tells us each angle in a perfect shape. Remember, we had the two different formulas. We had for just like any old weird shape, total degrees, n minus 2 times 180. And then we had perfect shape, regular they call it, each angle, n minus 2 times 180, total divided by n. So, yeah, so we use that formula. Or you could just look at the thing, huh? And just say, well, yeah, there's a bunch of triangles in there. You know what I mean? You don't even have to memorize that formula. You can just look and go, well, if you just start here and just start making triangles, You remember, you start from an edge point. Don't start from the center, but start from an edge point and just see how many triangles you got, because you know every triangle holds 180. How many triangles we got? 1, 2, 3, 4, 5, huh? 5 triangles. Each hold 180. So it's just going to be 5. The total's got to be 5 times 180, which is the same thing if we use the formula, because how many sides does this thing have? 1, 2, 3, 4, 5, 6, 7 sides, 7 angles. If you plug in the 7 for n, 7 minus 2, 5, same thing. The total's 900. So far, so good. Did I say all that too fast and too confusing? So in other words, there's 2 ways you could do this problem. You could use the formula. We're not done. We just have one more step to go. But the major step is you could either use the formula, n minus 2 times 180, and just plug, and the n is the number of sides, or the number of angles, same thing. And that's 7, huh? We have 7 sides, 7 angles. Just plug in a 7 for n. 7 minus 2 is 5. 5 times 180 is 900. So all those angles must total 900. Or you could just make triangles and go, yeah, there's 5 triangles. That's why there's 5 180s. So 900 total degrees. And then so x must be whatever, 900 minus, what did all those other ones add up to be? 772? Yeah, so just add up all the other ones on your calculator and subtract, huh? What is that, 128? X must be 128 degrees. Are we good there? All right. Let's keep moving ahead. Let's see. So there's another one. ABDC is a trapezoid. Anyway, we don't really need to read all those specific words. They're just a little bigger for us. They basically want us to find, I guess, X, Y, and Z. Yeah. So using that picture, that is number 11 there. So on number 11, can we find X, Y, and Z in that setup? How about I give you a second? Where'd you guys start on that one? Finding which one? X. How'd you find X?
90 minus 56.
Now, do we know for sure? I mean, I think you're right, but do we know for sure that these guys really make a 90-degree angle? I mean, it sure looks like it, but they didn't put a box in that corner, huh? So we don't know for sure. I think it probably will be, but we're not sure. Where else could we start?
I started at Z.
Yeah, Z we can start for sure, and then we'll get to this. Yeah, how do we do Z?
Out of the 2 angles inside.
Yeah, Adam, these two guys, 42 and 56, was that 98? And then subtract from 180, huh? For Z. Is that 82? Yeah, 82. So Z's got to be 82. And now, what can we do from there? Well, maybe we do have to do that. Maybe I think maybe you're right, and I'm forgetting something. Oh yeah, A, B, and C, D are parallel. Oh yeah, we do know that. My mistake. Never mind. Yeah, that was we could have totally started with that X. Yeah, I forgot that they had said that the top and the bottom are parallel. Right? They said it right here. I wasn't even paying attention to that. So the top and the bottom are parallel. Yeah, so this totally does have to be a 90 degree, doesn't it? For those guys to be parallel. It has to be. Yeah, good job. We could have totally started there. Yeah, so what is that then? What does that X have to be? Whatever 90 minus 56 is. 34. Yeah, so that one has to be 34, right? And then we can get Y because of the 180 total in this triangle here, huh? So 90 plus 34. What is that? 124. And then so Y will equal whatever's left over from 180. Y will be, what's that, 56? So Y's got to be 56. And we got them all. Good job. There we go. I think number 12. I think number 12 here is easy for you. I'm going to move on in the interest of time. I think you could find Y and X pretty easy on number 12. I want to be able to do the hard ones with you instead of the easy ones. Number 13, let's get a little bigger picture here. There's number 13. They basically, on number 13, want us to find all those angles everywhere in that picture. So how can we do that?
You know that 1 is 99 degrees.
Good. Let's start there. Yeah, we'll just start reasoning out all the things we know. Yeah, these two are diagonal, aren't they? So this one's got to be 99 degrees. Because they're, can you see how those, the two diagonal, because that other line can kind of confuse the issue. But if you kind of trace them in, you can see real clearly, oh yeah, those are two lines, the diagonals, called vertical angles, have to be equal. Those are both 99. Good. Okay. Now what? Oh, we can get that one, right? Same way. What else can we do?
You know that a straight line is 180, so you can do 180 minus 124.
Which angle are you trying to get right now?
7.
Number 7, right. Does that sound good? We can get number 7 that way? So number 7, right here, yeah, because here's a straight line. So the top or the bottom or the right or the left, one side of a straight line is always 180, huh? So this side, right there, number 7 is whatever, 180 minus 124. What's that, 56? So that one's got to be 56. Very good. Now what? Can we get angle 8? Got to be the same thing. Yeah, diagonal again, called vertical angles. Got to be 56. Okay. What now? Good question. Yeah, is 3 the same as, is it 56? Is that 56? Are those corresponding? Like if you go from this intersection to this intersection, are those corresponding angles? Yeah, good job. Good observation. Right? Because here's, what's confusing is that other line in there. But if you kind of like block it out of your mind, or let me just highlight the main lines. Maybe that'll help our vision if you're having any trouble seeing it. Because that's exactly right. Yeah, these two are the main lines. And then here's the transversal cutting across them. Yeah, those are both the upper left-hand corner of those intersections for those two lines and the main line. Yeah, so those got to be the same, don't they? Good job. And then once we have that, it's like an avalanche. It all falls apart for us, right? How can we get, for example, angle 2? The 180 total thing, right? Because these three have to make 180 because they're the top of a straight line. So whatever 180 minus that is. And then once we have the 56, we know this one's 56 because it's diagonal and everything else. Oh, wait a minute. Hold on. Angle 9. How do we get angle 9? Oh, yeah, find 4. You're right. Yeah, find 4, and then there's the 180 in the triangle in there. 9 and 2.
Or 4 and 2. Yeah, 4 and 2 are the same.
4 and 2 have to be the same. That's right. Yeah, 4 and 2 have to be the same. You guys have got it. All right.